So basically today we are going to execute all the operations regarding lists, right? This is basically, so this is going to be a revision session, okay? Yeah. So I have created another dummy file which is dummy3.py. You you know, I think you know how to create py file. If you don't know, let me demonstrate first. But I'm not going to create one, but I can show you. Go to file, go to new, go to file, then go to new, and under new you'll find Python file. Just go to Python file and you can put any name. You don't have to mention the extension because by default it is a Python file, so it by default the extension will be .py, .py. So you don't have to mention that. You can name it 1, 2, 3, 4, doesn't matter. It if you mention name it 1, it will be 1.py, non.py. If you name it a, it will be a.py. So this is how you create a py file in IntelliJ. Okay. Now let me start with declaring a string. Okay. So the first lst1 and a string of numbers. Let us start with listing of numbers, not list. So a list of numbers, not list of strings. So lst1 and lst2, I think lst2 and lst3 we have already executed. So this is going to be lst4. Actually that is not going to bother us because those were different files. Even if I take it lst1, it will not hamper. So I'm just taking lst1. Okay. Those lst1 and lst2 are part of some other code, right? So we are executing a whole different file or whole different code. Now lst1 what we can assume, we can take maybe some let us take some random numbers. Okay, so maybe it is going to be 23, 36, 99, 76, not 76, 78, 900, maybe 1, 2, 5, 8, 3, 9, 2, 4. This is very random, you know. And 7, 5, 9, maybe this will 4, 8, 3, maybe, and 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers we have taken. So maybe there let us take 10 numbers only, because as we have taken very random numbers, so multiplication and especially the division is going to be very random. I don't know, maybe some of these numbers are prime numbers also. Okay. 3, there will be recurring and many things can happen. Okay. So 5 3 3 5 3. So okay, now as I have already told you, whenever you are executing any operation on a list, at first you have to parallelize it. Why? Because I don't know whether you have watched the previous videos or not. If you have watched those previous videos, then even if you haven't watched those videos, you can understand this easily. You can understand this, but I'll recommend you that you just keep this part. Okay, you just keep this whole video and go to the extreme end of the video, and then you'll find at the end of the video there is a playlist as well as videos suggested there. Okay, I'll try to I'll try to mention the first video here and the whole playlist. The playlist contains only two or three, maybe three to how many sessions we have covered. Okay, we have covered 3 sessions, so there will be 3 videos, but you have to start with the part 1 only, the first video. You have to start with the first video, the oldest one on PySpark. You have to start with that, and then watch the second video, and after that you can visit this part, okay, this video. Okay, fine. So now, as I have already told you, but let me explain again. No, in normal case, if you don't parallelize it, what will happen? It will be executed sequentially, and now there are 10 numbers, so it will, what is sequentially? It will take the first number 23, and the operation will be executed on 23. Then it will move to the next number, which is the second one. Then the operation will execute on that one. Then third, then fourth, then 5, then 6. This is how it will proceed. It is like a loop, for loop or when loop. In case of for or while loop, what happens? It will take the first value of the I. Suppose we are starting with I equals to 0, so it will take I equals to 0. Then it will check the conditions. If it doesn't have to satisfy, even if it satisfies, it will just keep iterating, right? It will keep iterating. Then if you put it as I plus 1 or I plus 2, it doesn't matter. If you put it I plus, which that means it will keep iterating, it will keep increasing by 1 number each time, right? So then it will go to 1, then it will go to 2, then 3, 4, and up to nth number, I equals to n. It may be 10, 100, 1000, doesn't matter. So here also same thing happens if you don't parallelize it. After 25, 23, it will go to 36, then 99, then 78, then 900. Okay, fine, absolutely fine. Now, if you parallelize it, what will happen? If you parallelize it, the operation will be executed, or the operation will be executed is okay. The operation will be executed on each and every element of the string list, each and every number of the list, or each and every element of the list simultaneously or parallelly. Okay, so that will take much less time, right? Now, how to parallelize it? Let me tell you that RDD, we can approach these operations with in two ways. One is RDD, another one is data frame. RDD and DF, which is data frame. Now, RDD comes from Spark context. RDD belongs to Spark context, right? So we have already assigned a variable SC to Spark context. SC equals to Spark context conf. Don't look at conf equals to conf. That is not important for you. Okay, now SC equals to Spark context, isn't it? So if you don't take SC equals to Spark context, what will happen? You have to mention the whole thing Spark context each and every time. Now you have taken a small variable SC, which is referring to Spark context, so you don't have to write that much, right? So now RDD, we're starting with RDD. RDD is just a variable, okay, but as we are executing with RDD, so we are naming it as RDD so that you can understand what is happening. Okay, you can write it RDDs also, you can write anything, RDD1 also, doesn't matter. What you are doing basically, this is an RDD approach which belongs to a Spark context, so we are calling Spark context dot parallelize. This parallelize operation, or this parallelize method, belongs to Spark context, right? And this approach is RDD approach. Okay, now you can write LST1. Okay, LST1, right? LST1, isn't it? Now let us print the input also. so that you can see this was the input, and after that you can see that okay, these are the outputs we are getting right now. Okay, yes, fine. So let us print a blank space first. I don't think blank space is required because we haven't printed anything right till now. No, blank space is not required. Let us directly write raw data. No, I'm going to copy it, so it is better to write print the blank space. Yep. Why did I put inverted commas? Okay, so print, at first we are going to write the heading, print the heading, what we are printing, that we have to mention here. We are printing a raw data only at first. As we are revising, so we are not going to print, we are not going to type every time. Okay, I'll type only one time, then I'll just copy this part, print part only. The code, the operations part I'll type again and again, so that there is no error. Print part, but you have to keep in mind, previous 2 days, couple of days, we had the same issue. There was no syntax error, but we, or anything like that, but we couldn't debug it. Then after some time we realized okay, there was a typo, or there was in the first, as we in the first case we're just typing the raw data, not we haven't parallelized it, so we didn't require using we haven't parallelized using RDD, so we didn't require collect, but we have copied that one, and then we just edited that one. So that is why we forgot to mention collect, but we have to collect after this. This is LST1. This LST1, we are printing LST1 directly. We are printing LST1, then print blank space. Okay, fine, done. Absolutely done. Now we have to execute the what? We have to execute the first operation. We you know that we start with, usually we start with addition. So I'm going to start with addition now. Add LST1. Add LST1. So now what we will do, we can call RDD now, because RDD is referring to the parallelized LST1, the parallelized list LST1, isn't it? So RDD, now we are calling RDD, we are calling what? We are calling the parallelized version of LST1, isn't it? Now RDD dot what? RDD dot what we are going to execute? We are going to execute addition, and addition is a map operation. It is not a filter operation, isn't it? So lambda, yes, lambda x, lambda on what? X refers to the elements, all the elements, each and every element of the list. Now x, lambda x colon x plus, I am going to add 50,000. Okay, I'm going to add 50,000. Now let us just copy it as I mentioned. Yep, this part. Now edit it with add data, is add data, and now this will be, obviously this is going to be add LST1 dot, don't forget to write it, collect, yes, collect, yes. Now write what we can write, we can do subtraction now. Let us write all the codes, at least addition, subtraction, multiplication and division. Up to division we can write RDD, then we will execute the whole thing. Lambda x colon x minus, we are going to subtract the same thing, 50,000. Okay, now especially in case of multiplication and division, the output is going to be horrific. But no worries, so we can use sub here, sub sub, you can use sub, and this will be sub lst1. Now sub lst1 now dot what, collect, dot collect. Yes, no, we don't have to write collect also, but okay. Mul is lst1, mul lst1, which is mul means multiplication only. Yeah. RDD dot map x colon x multiplied by 50,000. So we are multiplying 50,000 with each and every element. Why is it showing like that? Okay, lambda I have written. Oh, sorry, I forgot to write lambda. Yeah. Now it is okay. Now it is okay. Sorry. This is not sub str. This is sub lst1. Okay. Yes, sub lst1. Okay. Now again we'll paste it and we'll write mul data. This mul data. This is multiplication data. Mul data. And this is going to be obviously mul lst1 mul lst1 dot collect. Sorry, lst1 dot collect. Yep. Yes. Now the third one is going to be div lst1. This is going to be div lst1. Map lambda x colon x divided by 50,000. Hey, shit. And this is going to be div. Obviously this is going to be div. So this is division data, and this is div lst1 dot collect. Yes, so let us execute it now. It's being recorded now. Okay, yes. Today the whole execution is going to take much less time, because I don't have to explain each and every step. I don't have to explain that. So yes, as you can see, start with the input one. Okay, input is okay, the same string which we have taken. So this the raw data is fine. Now we are going to print the now we have printed the addition. the output of the addition, x plus 50,000. So 50,000 plus 23, 50,000, 23, 50,000 plus 36, 50,000 plus 99, 50,000, 99, 50,000 plus 70, till 50,000, 353, yes, 50,000, 488, 83, 450,000, 559, 99, 424, 50,000, it's not 50,000, 51,000, 58, 51,000 to 258, right? Okay. Hello, 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 hello. Yes, yes. Okay. Yep. Now, addition. After addition, oh, addition we have already seen. Okay, so subtraction. After subtraction, what happened? You are subtracting 50,000 from 23. So basically, it is minus 50,000 minus 23, right? So it is 50,000. If you subtract 23 from 50,000, it is going to be 49,977. 49,964, 901. So I think these are absolutely okay. Okay. Now you have to to check explicitly. If you want to check each and every element, then you have to calculate it. So I am not going to calculate these subtractions. Now 11 1,15,000. We are getting a 1 lakh, not 1,50,000. We are getting 11,50,000, isn't it? After multiplication, we are getting 11,50,000. If you multiply 23 with 50,000, we are getting this one. If you multiply 36 with this one, you'll get, because 36 times 5 is 180, isn't it? 36 times 5 is 180. Let us check with this one. 36 times 5 is 180. Now 180, after 180, how many zeros will be there? In 50,000 there are 4 zeros, so there will be 4 zeros. So this is 18 lakh. Now 99, it is 495, 49 lakh 50,000. Let us check with 900. You can check this one. 5 into 9 is 45, and now in 50,000 there are 4 zeros, and in 900 there are 2 zeros. So see, there will be 6 zeros. So after 45 there will be 6 zeros. Yes, we are getting 6 zeros. So this is basically 4 crore 50 lakhs, isn't it? And after that we are getting 6 crore 29 lakhs. Then we are getting, yes, then we are getting even bigger numbers, which is 90 crore 62 lakhs, and so on. Okay. Yes. After division, we are getting 0.0004446, 0.00730, 0.00198, 0.018, 0.02561. You cannot check straight away. So this must be okay. We have checked for 2 or 3 numbers, so it is okay. Now, if the code is fine, then the calculation will be okay. Yes. Now what we will do, we will execute the filter operations now. Okay. So we are going to take filter. I think we assumed up to, no, not required, because this is a different file. So field 1, the field 1 is going to be RDD dot filter. As this is a filter operation, this is not map operation, so this is filter. RDD dot filter what? Lambda x colon x greater than 1000. Okay, x greater than 1000. We are going to print in the same way. So this is going to be field 1. It's going to be field 1 data. Field 1 data, yes. And also this is going to be field 1 dot collect. Let us copy the whole thing because there is nothing to change except of this sign. Instead of greater than, we are writing less than. Okay. Okay. Now we will execute for greater than equals to and less than equals to. This is the same thing. Is greater than, less than. If you take another separate condition for greater than, less than, then you will get mention for greater than equals to, then less than equals to, then greater than equals to and less than equals. Doesn't matter. You don't have to work that much. If it is working for both the conditions simultaneously, greater than equals to, and less than equals to, you are putting a window basically. Or if you are from electronics background, you'll understand there is a high pass filter, there is a low pass filter, and there is a band pass filter. Right? In high pass filter, what happens? High pass means frequencies greater than a certain the signals having greater frequency than a certain frequency level. That will you will mention that frequency. Suppose the frequencies you have mentioned that for this high pass filter, the frequency is greater than 20,000 hertz will be passed, right? So the frequencies, the 15,000 frequency is not going to be passed. That 10K frequency is not going to be passed. 5K frequency, 5,000 hertz frequency is not going to be passed. Or the 5 kilohertz is not going to pass. The 15 kilohertz is not going to pass. But a 25 kilohertz or 50 kilohertz or 40 kilohertz frequency is going to pass, right? Same happens to low pass filter. You are going to pass the frequencies lower than a certain value, a certain value. Like it is if it is a low pass filter, so the frequency is less than what we have mentioned, 15,000. Sorry, the 15K hertz, 15 kilohertz is going to pass. So for the 5 kilohertz, 1 kilohertz, 100 hertz, that is going to pass. But 20, 25, 30, 40, 50, 100 kilohertz is not going to pass. Now there is a band pass filter, which is this is a lower end, there is a higher end, and the frequency is lower than the lower end and the frequency is greater than the higher end are not going to pass. The frequencies, only the frequencies in between these two values are going to be passed, which is from, suppose this is a 5,000 kilohertz and this is a 15,000 kilohertz. Now the frequencies in between 5 kilohertz and 15 kilohertz is going to pass. 10 kilohertz is going to pass, 12 kilohertz is going to pass, 18 kilohertz so I've taken 15, right? Sorry. 10 kilohertz is going to pass, 15 kilohertz is going to pass, and 7 kilohertz is going to pass. But 30 kilohertz is not going to pass, and 2 kilohertz is not going to pass, 1 kilohertz is not going to pass, right? So same happens in less than equals to also. It is a kind of band. So now field 2 equals to RDD filter X. We can execute it in two ways, but okay. One, you can write like this. 500 less than equals to, I haven't taken 500, so less than and less than equals to is basically same. This 500 value is not included in the list, so it will be the same output. Now x, sorry, not capital X, it is x. It is also less than equals to how much? It is also less than equals to 1000. So you have created a band like that, right? From 500 to the values in between 500 and 1000 is going to be passed. Now here the editing part is easier, because this one is going to be 2 and this one is going to be 2. Yes, okay. You can execute it in another way. Let us write that one also. Copy. Yes. Now let us write it in this way. Before this, write and yes. So this is going to be x greater than equal to 500 and x less than equals to 1000, right? And this is going to be, let us name it field 3. Field 3. This is also going to be field 3, and this is also, oh, the first one was field 2, field 1, so this is going to be field 2. Field 1, this field 1, field 1. I forgot to rename it, field 2, and this is also going to be field 2. Field 2. This is going to be field 3. 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 This is also going to be field 3. Isn't it? Now this is going to be field 4. This is also going to be field 4, and this is also going to be field 4, isn't it? Yep. Now, okay. Now field 5 equals to RDD dot filter. I'm writing the whole thing now because I forgot to copy it. Lambda x colon, again I'm writing the whole thing, x colon x greater than equal to, oh sorry, and we have already executed, so we let us execute the OR condition. Okay, if you take the same thing in OR condition, what will happen? Even if one of the condition have satisfies, it will show output for that, right? Now in AND condition, both the conditions has to be satisfied, so it has to be in between 500 and 1000. Now in case of OR, what will happen? The values greater than 1000 will also get printed, isn't it? Values greater than 1000 is also going to be printed, which includes all the values less than 1000, even the values less than 500 also, and the values greater than 500 includes all the values greater than 500, even greater than 1000 also. So the whole string is going to be printed. So we are not going to do that, where we are trying to understand this. So we are going to, instead of that, we are going to we're not going to, okay, let me write first. Okay, let us assume that the values which are less than 500 or the values which are greater than 500, isn't it? The values which are greater than 500. Now in case of AND, if you wrote like that, what would happen? The values less than 500 and the values greater than 1000, they don't have any common factor. They have to be, they should have some common factor to show some elements as output, isn't it? So there is no common element in between these two conditions. So there would be a blank string, a blank list in the output. Now we are showing greater than 1000. Yes, yeah. Now let us print the output. This is going to be field 5. This is going to be field 5. This is also what's wrong? Oh, okay. This is going to be field 5. This is going to be field 5, and this is also going to be field 5. Yes. Now run it. Yes. So in field 1, what happened? Values greater than 1000, we are getting yes 1258, and 3924 is greater than 1000. Yes. Less than 1000, 23, 36, 99, 78, 900, 759, 483, 3553. Yes. Now filter 3, uh, it is between 500 and 1000. So between 500 and 1000 we are getting 759 and 900, and we have executed the same thing with different way, in different way. So this is, we used AND operation, AND. So using AND we are getting the same thing, but now it is less than 500 or greater than 1000. So we'll get both we are going to get the elements satisfying both the conditions, isn't it? This is a or condition. So the values less than 500 is also going to be printed, and the values greater than 1000 is also going to be printed. So the 23, 36, 99, 78, these are the values less than 500, and also 483, 353. These are the values less than 500, and values greater than 1000 are 1258 and 3924. Okay, fine. Now the most important part. Now we are going to execute list of strings. Yes, list of strings. Let me write here list of numbers words. Let us print like that. Okay, 1 second. I'll print it. That will look really good. Yep. Yes, I print it. Now print a blank space. Now let us print like that here. Instead of numbers, it would be strings. It will be strings. Strings. Yes. Now let us move to the next part. Now we will take sorry, how much time we have covered? Okay, this is already 40 minutes. Okay, no problem. So let us take another string, which is lstr1. lstr1. Now I am going to take a list of strings. The first element is going to be double inverted comma. Okay, first element is going to be, let us take football clubs and cricket clubs, EPL clubs and IPL clubs. Okay, not EPL, but football clubs in general, football clubs and IPL clubs. Okay, now the first club is going to be Arsenal FC. Yep. Now the second one is going to be Barcelona FC. So the third one should be Tottenham FC. Tottenham. Let us write Tottenham in small letter. As their rivals. Now write Real Madrid. Real Madrid also in small letters. With FC. Real Madrid FC. FC in caps obviously. Now write some cricket clubs. Name of cricket clubs. Okay, let us write East Bengal FC also. East Bengal FC. East Bengal FC in caps, and Mohun Bagan Super Giants in small. Okay. FC, yes. FC is required, though we don't say Mohun Bagan Super Giants FC, but it's football club, so it is obviously this FC. Now the third name should be a cricket club. So let us take KKR. We're taking small name, small letter. We're just using small letters. Okay. Now we're going to take what? KKR, CSK. Sorry. CSK. Then Kings 11 no. Mumbai Indians. These are the three most successful clubs, isn't it, in IPL history? Mumbai Indians, Chennai Super Kings, and KKR. These are the most successful clubs in IPL history. Yes. Now, though finally RCB achieved something, but okay. But these are the three clubs which comes in your mind when you think about most successful clubs in IPL. You'll think of Mumbai Indians, CSK obviously, and after that you'll think of KKR. Now let us print this. Okay, print yes. Then print blank. Let us write. It is LSTR. Sorry, raw data. This is raw data. Sorry, this is raw data. Obviously, this is raw data. This is raw data. Now we are going to print the output. Oh, sorry. There we have to print a blank space. We are printing this blank space to segregate the heading and the output. There should be a gap, so skipping one line. Now we will print the the input. This is the input. So we are going to print the raw data, which is LSTR1. We haven't parallelized it yet, so LSTR1 we are directly printing. Now we will print another blank. I know this looks really weird, but okay. Now we are going at first, as we have already declared the string, we have printed the string. Now we can parallelize it. The parallelize LSTR1 dot parallelize LSTR1. Sorry, extremely sorry. This is SC, obviously. This is SC dot parallelize. Sorry, something wrong. By mistake I pressed insert. Now I have to write the whole thing again. Parallelize LSTR1. Yes, okay. Yeah. Now we have parallelized it. Now we can call RDD easily, the parallelized version of LSTR1, isn't it? Now let us copy this. Let us copy this part. Yep. Now we will take lstr sorry, we are going to concatenate. So this is going to be con1. We'll concatenate only once. We don't have to concatenate many times. This con1. Now we are going to concatenate what? Okay, at first call RDD dot map. Concatenation is also a mapping operation. So this map lambda, this lambda x colon x plus these are strings, so we have to keep it in inside in double inverted comma. Now this double inside double inverted comma, let us write franchise, maybe franchise. We have mentioned few football and cricket clubs, and after that if you write franchise, that makes sense. That is why I am writing franchise. Okay, franchise. Okay, yes. So we are going to concatenate franchise with each and every club. Now paste it. Write con1 con data, just con data, because con data. Yes, write con data. Yes, con data. Write con data. Con data. We are printing con data. Now this is going to be con1. Con data, con1, con data. Okay, so concatenation is done. Now what we can do with the expected output? What is the expected output? The expected output is Arsenal FC franchise, Barcelona FC franchise, Tottenham FC franchise, Real Madrid FC franchise, East Bengal FC franchise, Mohun Bagan Super Giants FC franchise, KKR franchise, CSK franchise, and Mumbai Indians franchise, isn't it? Yeah. Now what we will do, let us replace something. We can either we can replace or you can fire. Okay, you can print which strings include which strings include FC in it. Okay, so this is lstr in. Name it lstr in. Okay, let us name it lstr in equals to lstr in equals to this is also our filter operation. Sorry, not filter. This is map operation. Obviously, this is map operation. So lambda, this lambda x colon x in. Sorry, not x in. This is going to be FC. Sorry, FC in x, isn't it? We are not finding whether if x is in FC or not. We are trying to find whether FC is in x or not. So x means the elements. X is referring to the elements. So whether FC is inside FC is contained in the string or not. So this will be x. Yes. Now print the whole thing again. Yes. So lst in, this will be lst in. It's going to be lst in, and this is also going to be list in data. Okay. Now we can replace. RDP1 rep1 is rep1. What that sounds weird. Okay, RDP1. Okay, RDP1 equals to RDD dot map. We are going to replace lambda x colon. We are going to replace lambda x with we are going to replace lambda x with x dot replace. So basically we are not going to replace the whole x or the whole element, but we are going to replace some part of the element string, right? Now we have taken fc already. Let us see which part is common. fc is the only thing which is common between many elements, isn't it? So you have to execute on fc, and after that you cannot execute again, okay? Because once you have executed, you have replaced fc, then you are trying to find out which strings contain fc. That is not going to work, okay? So you have to execute. You can execute it once only. At least if you have replaced fc, then you cannot get back to this part where you have executed the operation on fc, because fc will be completely lost, isn't it? So let us execute it only once. I am going to replace fc. I am going to replace fc only, and comma. The first part is the element or element of the part. First part is the part of the string or first part of the element which is going to be replaced, and second part is the part which is going to replace the first one. So let us write football club instead of yesterday also we did the same thing, but okay, football club. We're going to replace fc with football club. Yes. Now paste it. Now you can write RDP data, okay, replace data. Let us write RDP1 1. Yes, RDP1. Yes, I have written. Yes. Now okay, let us print. Okay, another one we can execute right now. Okay. No, for that we have to take another string. So okay, it is okay. Let us run this one first. There is map splitting. There is map splitting. So we execute it using flatMap. So that's once you learn how to split a string, then we can proceed with some scenario based questions. Maybe the scenarios we will execute later on. Okay, sorry. We're getting the same error only because the same thing. In the first one we have written collect, but after that we copy pasted the same thing. Okay, no worries. Now we know. We don't have to debug it. We know what's wrong with these operations. So let us write collect. To execute RDD operations, you have to either see RDD. Why it happens? It happens because RDD is a lazy operation, or lazy evaluation happens. That is why what happens in lazy evaluation, all the process will be simultaneously, that will be planned, that will be executed. But as long as you don't trigger the action, it is not going to be implemented. As long as you are not trigger any action, it is not going to be implemented. That is what lazy evaluation is. Now in RDD is also lazy. So once you trigger an action like collect or take, okay, then only it will be implemented. Now it will show the output. We have collected the data. Now it will show the output. So at first it was we printed the raw data, then concatenation with franchise, Arsenal FC franchise, Barcelona FC franchise, Tottenham FC franchise, Real Madrid FC franchise, and so on. KKR franchise, Cisco franchise, Mumbai MI franchise. Okay. Now list in data. Okay. So Arsenal FC contains FC. So this is true, 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 true. Now KKR, CSK and Mumbai Indians doesn't contain FC, so these are false. Now replace data. Arsenal football club, we have replaced FC with football club, so they have printed that one. Okay. So replace is done. In data, we're finding whether a part of a string, part of a string is present inside the all the elements or all the strings or not. That we are checking, and concatenation is also done. Now we are going to execute the split. The split operation. Yes. So we'll write split map split map split map split. Yes. Print blank space and then print this thing. This will be a heading. Okay, like this, list of strings and list of numbers, like that it will be printed. Okay. Now again print another blank space, blank space. Yes. No, oh, sorry. Instead of print I have written PR, I have written RP. So print, that was a mistake. Yes. Now we are going to execute. Okay, now lstr2, let us take lstr2. Yes. Now to show you how split happens, let us take very small string, and we don't require any long word or anything like that. Just let us take some alphabets and some symbols or the punctuation, whatever. Yes. A star, B C. Okay, this is what the first string is. Now let us write in the similar way. B, make it inverse. BC, not BC, let us write BCT, maybe BCD, yes, BCD, and then C A B. Okay, then B D C. You understood what happened? In the first and second string both the symbols are there, but in the third there is only the first, only in third and fourth element the only one symbol is being repeated twice. Okay, now we are going to execute split. You will understand what is split. Okay, now let us print the input first in the same way. Oh, sorry. Let us copy this one because it is going to be, the raw data is going to be printed. So this is raw data. LSTR, instead of LSTR2, this is going to be LSTR2. Okay. Yeah. Now let us parallelize it first. Okay, obviously the first thing you have to keep in mind is you have to parallelize it. If you're once again parallelize parallelize sc dot parallelize lstr2. Okay, yes. Now we will execute the first operation, splitting operation. ls split. So we are going to write split 1. We are going to write splt1. Okay, splt1, this is going to be splt1 equals to RDD. We can call RDD now, which is the parallelized version of the LST2. So call RDD now, RDD parallelize. This is the parallel. Oh, sorry, no, not parallel. Sorry, I missed. Sorry. So this is going to be flat map. As I told you, flat map operation. This is flat map operation. This is not normal map operation. This is not normal map. This is not filter operation, obviously, and not at all filter operation. And this is a specific case of mapping operation. This is flat map operation. Okay, flat map lambda, same way, lambda x colon x dot split, x dot split, like replace only, x plus x dot split. What we're, this is similar to replace. Inside the bracket, instead of map it is flat map, and split, in split it is the same thing. The part you are going, the thing, the part of the string, or the thing you are going to split, using which you are going to split the string, that you have to mention inside it. Okay, so at first we are going to split using this symbol. Okay, we are going to replace it using this symbol, and in place of this, what we are going to write? You are going to write, one second, what happened? Where is the error? Flat map we have written, flat map is flat map. Bracket. Okay, we haven't closed the bracket, that is why it is showing. Okay. Yes. Now sorry, one second. Sorry, not record. This is not replace, right? This is not replace, this split, so you don't have to mention it. Okay, now let us write the same thing, raw data split. Once again, split. Yes, split. Split data, isn't it? Split data, and this is going to be SPLT1. Let us print it first and see whether it is working or not. Not throwing any error yet. Let us check the output first. Okay, the raw data has been printed. Whatever. One second. Flatmap is okay. I don't know. Okay. Sorry. It should be caps. Okay, it should be caps because, as I told you, Python is case sensitive. If you write something in lowercase instead of uppercase, or uppercase instead of lowercase, it will be considered something else, as some other thing or something else. So it will throw error. The code was right, everything was right, but flatmap, the flat is in small letter. The aim of the map is in capital letter. That you have to keep in mind. So the first split we are executing right now. Yes. Okay. Again the same thing. Collect. Sometimes you forget to write something, and you should know why we are getting this error. You will be habituated. You will be accustomed with the errors also, the output errors. As soon as you see okay, this is the error I am getting, so this should be the solution. Okay, now you go to the code, and you okay, right, I have forgot to write collect. Now you write collect, and you re-execute it. Yes. Okay, so I have split it with this symbol. So where this symbol is present, it will split the string, and rest of the part will be considered as other string. So A star B will be a string, and it will be split it through this position, and C will be considered another string. This is what happened in B, C, D. Also B will be treated as another string and split it here, and C star D will be treated as another string. C here, C will be treated as another string, A will be treated as another string, B will be treated as another string, and BDC, in BDC also it is happening. Sorry, this is not going to work because this symbol is not present in BDC. Now we are going to execute the same thing. I'm not going to write it again. Copy. Okay, let us write it again because we are executing it for the first time. So split SPLT2 equals to flatMap. Now we have to keep in mind aim is caps. Okay, flatMap. Now lambda, this lambda x colon x dot split, this is going to be x dot split. Okay, now inside inverted comma you have to write star, because we are going to split with star. Now the other symbol is done, it is done and dusted. Now we have to copy it. You have to copy it. I'm not printing again. Print part is okay. You don't have to write it. Split data. Okay, bro, name it as split. Write this symbol here, and you can write here split star data. Okay, I know this is silly, but okay. Now all the elements should be printed separately. A B C B C D C A B B D C. All these will be separate elements, and there will be no symbol left. So during the course of demonstrating how to execute this flatMap, map split operation, I have already executed one scenario. This is also a scenario. This is also a scenario based question. They have provided some input and they told you that this is how the output should look like. Now you have to think, okay, how can we do this? And do, okay, 1 second. Why flatMap is not defined? What? 1 second, 1 second, 1 second. Okay, sure. RDD, I forgot to write RDD. That is why I'm thinking why I'm getting this error. Okay. Yeah. You can easily execute flatMap multiple times. It is not like that you can execute only once and after that it will throw error. No. So I forgot to write RDD.flatMap. I forgot to call RDD. You're executing on RDD, right? You're the flattened, no, sorry, the parallelized version of LSTR2. All the operations are being executed on RDD. So you have to call RDD flatmap. RDD, then you have to execute flatmap dot flatmap lambda x colon x dot split. You are executing the split on star. So that is why. Yep. Now. Oh, sorry. Again, you have to keep in mind. If you are executing on. Yes. Okay. Keep it like that. You can start with this way also. You can start with this way also. Doesn't matter. You can start with star also. You can start with this symbol also. Symbol doesn't matter. Okay. Ultimately, you have to segregate all the elements and omit the symbols. So either you can start with star or you can start with the other symbol. I forgot what is the name of that symbol. Usually we use it as difference, not minus. In minus there is a certain direction, like a minus b means you are subtracting b from a, and b minus a means you are subtracting a from b. But a difference b means it refers to both ways. Okay. Now we will just execute the same thing, which is going to be the ultimate output. Split. Okay. Output. You write it simply. You write it output data. Okay. This is the expected output. So you have to execute it on. If you are using it start to execute it, you are executing it on split 1, isn't it? Split 1, SPLT1, and let us keep the second part inside inverted comma. Sorry, 1 second. Yes, triple inverted comma to comment it out. Yes, triple inverted comma is used to comment it out. You keep triple inverted comma, then write something, and after that keep triple inverted comma. This means that you have commented the whole part of the code, or the whole code inside it. You have commented the whole thing out. Okay. Now this output SPLT2. We are executing SPLT2 collect. Yes. So this is going to be SPLT2. Let us name it SPLT3. Okay. Let us name it SPLT3. So we are executing it on SPLT1. Now execute it, because once we have already splitted it using this symbol, then the next operation should be performed on SPLT1, not RDD. If you perform it on RDD, you'll go back to the original string again. No, you're up to this point you have already executed. Now after that you have to proceed with another split operation using star. Okay. Yep. Oh, okay, done. A B C B C D C A B B D C. Now we can execute some. Okay, let us execute another scenario also. A difficult one. A data I'm taking from some other source. Okay. Yes. This is the data we will execute. Operation on. Okay. Operation cell. Now scenario. Basic. Okay. Scenario. Scenario 1. Okay. Yes. Now right. Yes, this is data. This is data. This is data. This is the input data. Now what we have to do, just keep in mind, okay, we have to just print what is the expected output. Do you know what is the expected output? Our expected output is Tamil Nadu, comma, Chennai, UP, comma, Lucknow. Understood? Or else, no, sorry. This is very easy. If I said Tamil Nadu, comma, Chennai, you'll directly replace state and city. No, don't do this. You can write, you can do this, you can create separate output for the state values, and you can create separate output for, or separate list of cities. There will be a list of states, there will be a list of cities, but you don't have to write it this way. Write in this way. State dash, then an arrow, then Tamil Nadu, not this way. The expected output should be in, okay, let me write. This is the way they will ask you to do. Okay, the first list should contain TN UP. Okay, the first list should contain TN UP. Okay, the second string should contain Chennai, Lucknow. This is the output you are expecting. Okay, this is the output you are expecting. So let me put it inside triple inverted comma. One second. Expected output. Okay, this is the expected output. This is the expected output. Okay, so now you know that to execute this, what you have to do, at first you have to split, right? At first you have to split. You have to split using this symbol. No, okay. At first you have to split using comma, isn't it? At first you have to split using this comma, because this string contains a comma, and now state and city both are inside one string. So you have to keep in mind that state and city we have to segregate. So at first you have to split using this comma. So what will happen? You'll get state Tamil Nadu, comma, that will be a separate string. Then city Chennai will be a separate string. State UP will be separate string, and city Lucknow will be separate string. Now we have state data and Chennai city data. Okay. Now you can filter. You can filter using state and filter using city, right? Filter using state, filter using city, or you can basically write state in x, one case state in x and another case city in x. Okay, now you can execute the operation on both the cases and replace state arrow with blank space. Okay, this is what you have to do. Okay, this is what you have to do. Now you have to at first you have to parallelize the data. RDD sc comma parallelize data. So data, you are parallelizing data. You have already parallelized the data. Do you want to print the input? Yes, we want to print the input. Okay, print blank space first, print the heading input data. Sorry, I've written input data. This is the input data. Yes. Now print another blank space. Again print the data here. You can directly print the data, doesn't matter. Again print blank space. Okay, yes. Now you are going to print the output. Okay, what you can do, you can write directly, you can write the first operation, which is splitting operation. So SPLT 2 maybe, no, SPLT 5 maybe, SPLT 5, let us take it SPLT 5. How many SPLT we have taken? Okay, SPLT 3, till SPLT 3 we have taken, so SPLT 4, okay, SPLT 4 equals to RDD dot flatmap, flat M is capital, flatmap lambda x colon x flatmap we have we have executed flatmap lambda x colon x dot split x dot split using what? Using comma we have to split. Sorry. Using comma we have to split. Yes. Now copy the whole thing and let me print the first string, then I'll tell you another way you can print the input. Okay, one second. Okay, we will use for each, but let me tell you why we are using for each. For that, let me show you the output in normal way. If we use print SPLT4 collect this way, second, there will be an issue. Yes, let us see. That's we'll rectify it using for each, then we keep continuing the prints using for each after that. once the data is in a tabular format, uh, the for each is required when you are using RDD. In case of data frame, you don't have to do that, because in data frame, the by default the output is in tabular kind of format. Okay, so you don't have to do that. Let us see what is the output. Why is it taking so long? Only this is only 260 lines of code we're running, so I don't know why is that. What happened? The data we have taken. One second. Close it. Again run it. It should not take so long. So much of time. It should not take so much of time. Yes. Now it started to execute. I know Python takes a little time to execute. Yes. In this case, you are not going to face that error, but once you replace the whole thing, and then try to show it in a tabular format, this will be difficult to segregate the data, right? Tamil Nadu and UP, and then Chennai and Lucknow. So better this be in tabular format. So that is why we can use another way, which is splt4 dot for each print dot for each print. Yes, print. Yes, this is the way you can print. Now you can see the difference. Okay, so sorry, let us copy it. Then we can execute. I have written input again. No, this is not input. This is not definitely not input. This is split one. This split data. Okay, this is split data, and then let us copy it. Now, okay, now we are going to execute the next operation. Let us execute all the operations, then we will see how the output looks like in this way. Okay, now after splitting with comma, we can replace state. No, we can find where the states are, and we can find where the cities are. Okay, now we can write state because state data, we can write state data. Directly we can write state data equals to RDD dot map. This is a map operation lambda x in state, isn't it? State. You don't have to write the whole thing. You have to write state only. State in x. This one you have to print. See, I've done the same thing. Yes, and I have printed this. Okay, Now you are printing state data. You are printing state data. State data. You are printing state data. Oh, sorry. 1 second. There was a mistake. State, yes. State in single inverted comma. If you write it in double inverted comma, it will show for true or false. Is it there or not? That is the different thing. Okay. You have to print it. Now split this. You have to write it that it is the state data. It is the state data. Now you have to copy the whole thing because you are going to execute the same thing. Now name it city data. Make it small s. Make it small s because it is a variable. So make it small s. That will be better. Yes, and this is also going to be city. This is also going to be city, and this is also going to be city. We are going to find the strings which contain city. Yes, and this is also going to be city. Everything is going to be city. Yes, everything is going to be city. Yes, city. Yes. So we are printing city data, which means it will show the first case the state data will contain state Tamil Nadu, state UP, and the second city data will contain city Chennai and city Lucknow. Okay. Now we have to replace. State data with state this part. You have to replace this part. Just copy it. First. Okay. We'll execute obviously. Now write state rep. Okay, state rep. Sorry, this sounds awful. State REP. Okay, state REP. Now we are executing it on state data. Okay. 1 second. This is not RDD. Obviously, this is not RDD. This is SPLT4. CC. Okay. We are executing on SPLT4. We have already performed the previous operation. Okay. Yes. Now it is going to be state data. Yes. Now this is going to be state data. You have to keep in mind on which string we are performing this operation, isn't it? So one second. Yes. State data. Yes. State data map. Okay. State data map what? State data map is lambda x replace. Now x dot replace, isn't it? X dot replace which part of the string we have to replace? You have to replace city. Sorry, state. You have to replace state. Sorry, I have already copied that one, right? Yes, state. This one we have to replace with blank space only. Nothing. Which means this part state arrow will be replaced by blank, means state arrow will be omitted. State arrow will not be there. It will just vanish. It will be omitted. It will be vanished. Now this will be city rep. This will be city rep. Yes, city rep. This is going to be city data. This is going to be city data. Yes, sorry. City data. Yes, this is going to be city data. And this is going to be city arrow. We are going to replace city arrow. We are going to once again. Yes, okay, I copied it correctly. Now put it here. Yes. Now write city. Now write city. City. Yes. Okay, city data we are getting, and we have to print city rep. Yes. We have to write city rep. Yes. This is what we are reprinting now. And at last, so there will be a string city rep which will contain Tamil Nadu and UP, and another one will contain Chennai and Lucknow. Okay, let's just print it now. Okay, we have what we expected. We already got it. Yes. I think it has been already 1.5 hours. Yes, I guessed it right. It is already 1.5 hours. Yes. See, 1 second, 1 second. Again, it is showing true false. Why? It should not show true false. In state data, we are getting this error. Okay, okay, sorry, sorry. I know what is the error. What is the issue? Okay. State in city. This is a filter operation, right? This is a filter operation. That is why we were getting this error. Yes. Now it is okay. Now it is absolutely okay. Yes. Obviously, it is a filter operation because you are searching for the elements which contains city. So it is not going to show all the elements. That is why it is a filter operation. Yes. Yes. I forgot to. Let us do it. Where is it? Where is it? Where is it? Replace, not replace. In, yes. This should have been filter. If you want to show the output. Yes. Yes. After that, okay. After that, we are executing the same thing. Yeah. Yes. Now see. CT data. Why CT data is showing like that? Oh, sorry. This should be city. No, on city data I have executed this, and okay, sorry, I forgot to write. Yes. By mistake I have written city, not city. Okay. That is why we are getting the same output as city data. Under city data we should get the city names only, not city arrow. The city arrow should be removed. That should be omitted. Yes. So this is how the output should look like, isn't it? So this is our expected output. Okay, so this is it. We can execute some more difficult operations also, some other uh, little difficult scenarios we can solve, but okay, we will do in next session. We will do another session to execute some scenario based questions from this part of PySpark. Okay, RDD operations, this part of RDD operations. After this we will move to data frame execution using data frame, and once we enter data frame part, then we will be executing the same thing using a data frame at first. Then using data frame we will execute many more things. Data frame is preferable in most of the cases. Even we will execute many operations on Parquet, ORC, Avro files, and by default Parquet is the default format of file. And why Parquet is considered the king of all file formats, that we will explain. Uh, what is Parquet? What is difference between Parquet, Avro, and ORC? How much of compression happens, or how much of compression occurs? Uh, that we will explain, and we will also deal with some complex data, like multiple nested or hierarchical data, like data sets, like in JSON format, multiple nested JSON data, and many more. Okay, so okay, keep watching. And if you're watching, you can directly if you haven't watched the previous videos and you want to understand it, then you can basically you can watch it. I think I have covered it all, but okay, you can watch it. If you face any issue while watching it, you can just go back to you can just keep the whole video and go to the extreme end, and there is a video referred there, and playlist also. So you can go to either you can go to the playlist, or you can just directly visit the video. You can go. I'll suggest you to go to the playlist. You can see there will be three videos. Till now we have covered 3 videos. So you on PySpark, just go to the oldest one. That will be the first one. Then visit the second one, and then you can watch this one. Everything will be crystal clear. Okay. So yeah, it has been already 1 hour 45 minutes. So okay, bye. If you like it, like, share, and subscribe. Don't forget to like, share, and subscribe, and press the bell button if you like it. Okay. Thank you. Bye.